Okay, today we're looking at geometric sequences, and we picked the exponent unit to put this in because when you're looking at geometric sequences, their common ratio is you find it the same way you find the rate of change in a table for exponential. It's going to be multiplying. Okay, so it's geometric sequences are basically exponential. Okay, all right, so let's take a look. A geometric sequence is a sequence of numbers in which the ratio which we refer to as R, remains constant, which is the same definition when you're defining a type of function from a table. An exponential function, its table, the ratio, it has a ratio because you're multiplying, as a ratio that's constant. All right. Common ratio, if it's found the same way when you're finding the rate of change on an exponential table, okay? It's found by dividing each term by its previous term. Okay? Divide each term by its previous term. All right, so first they want us to identify if it's a common ratio or not. All right, so let's look at these. So you take 10 and divide it by 2, and you get 5. 50 divided by 10 is 5. 250 divided by 50 is 5. So you have the constant ratio of multiplying by 5. So yes, it is a geometric sequence, and the common ratio is 5. All right, let's look at the next one here. 18 divided by 6 is 3, and 24 divided by 18 is 1.33. So that right there, they're not the same, are they? So no, it's not a geometric sequence. All right. Okay, the next one, negative 40 divided by 80. Negative divided by positive is negative. So it's negative 1/2, or negative 0.5. 20 divided by negative 40 is negative 1/2. Negative 10 divided by 20 is negative 1/2. Notice how they went from positive to negative. It's because you're multiplying by negative. Anytime you multiply by negative, it's going to change signs. All right, so yes, it's constant. So it's constant. Yes, it's a geometric sequence, and the common ratio is negative 1/2. All right, given the geometric sequence, find the next 3 terms. All right, so what we have to do first is find the common ratio. So negative 21 divided by 7 is negative 3. 63 divided by negative 21 is negative 3. So what they're doing is they're multiplying by negative 3 each time. So 63 multiplied by negative 3 is negative 189. Remember, watch your signs. Then you're going to say negative 89 times negative 3 is going to be positive 567. And then 567 times negative 3 is negative times positive is going to be negative, right? 1701. Okay. Oh, let's see. Let's look at this one down here. Negative 25 divided by negative 5 is positive 5. Negative 125 divided by negative 25 is positive 5. All right, so we're going to multiply negative 125 by 5, and you get negative 625. Multiply that by 5, you get negative 3125. And then multiply by 5 again, you get negative 15625. Okay? So if I'm just looking for the next few terms, I can just multiply out with my common ratio. But there is sometimes that you need a term that, you know, you don't want to sit there and keep multiplying and going. Like, just say if on number 10, I said, what is the 25th term? Well, that's not fun going and multiplying 25 times. So we can make a formula to find the nth term. And when I say nth term, it means when you make that formula, you can replace the n with whatever term you're looking for, and it will produce that. All right? So the formula to find any term in a geometric sequence is a to sub n equals a sub 1 times r to the n minus 1 power. All right? A, if you remember when we did arithmetic sequences, A was the first term. A1 is your first term. And then R, in this case, is your ratio. Okay, your common ratio. All right, so using this formula, we're going to find term 7. See where it says A sub 7? Let me write it a little bigger. A, and it's got a 7 in the sub there. It means it wants you to find the 7th term. See in the formula how it has n? You're going to replace n with 7 in here and here. Okay? So let's find out first what our common ratio is. 9 divided by 3 is 3. 27 divided by 9 is 3. So our R is going to be 3, and our A1 is your first term, which is also 3. So if I just asked for the formula, you would write AN equals your first term, 3, times 3, your common ratio, to the n minus 1 power. So now I'm going to plug in and replace n with 7 because I'm trying to find my 7th term. So it'll be 3 times 3 to the 7 minus 1, which is 3 times 3 to the 6th power, which is 3 times, what's 3 to the 6 is 729, and times 3 is 2187. So your 7th term in this sequence is 2187. It's the 7th term. Okay. Turn your notes over. Let's look in number 13. All right, 200 divided by 400 is 1/2. 100 divided by 200 is 1/2. So my ratio is 1/2, and my first term is 400. So we're going to plug it in, our formula again. So it's A1 times your ratio to the n minus 1. So AN equals 400 times 1/2 to the n minus 1. So if we want to find our seventh term, it's 400 times 1/2 to the 6th, because 7 minus 1 is 6. And that's going to equal, when you plug it in, is, where did it go? 6.25. Okay. If I was doing this by hand without a calculator, I would say 400 times 1 over, it's 1 to the 6 over 2 to the 6. All right, which is 400 times 1 to the, 8, 16, 64. And if you say 400 times 1 over 64, that's the same thing as 400 divided by 64, which is 6.25. Okay? So just in case you have one of these on the no calculator part of the EOC test. All right, okay. -4 divided by -1 is 4. -16 divided by -4 is 4. Ratio's 4. My first term is -1. So it's going to be, the formula is going to be AN equals -1 times 4 to the n minus 1. So now they say they want us to find the seventh term. So it's -1 times 4, and 7 minus 1 is 6. And then 4 to the 6 is, and then times -1 be -4096. So the seventh term equals that. All right. If I wanted to say what is term 20, all I would do is, instead of 7, I would put 20. Instead of 7 minus 1, it'd be 20 minus 1, so that would have been 19, right? Okay. All right, -12 divided by 6 is -2. Same thing for 24 divided by -12. So my ratio is -2. Term 1 is 6. So my formula for this sequence is 6 times -2 to the n minus 1. All right, so term 7. Let's do this. Let's find term 10, okay? All right, so term 10 equals 6 times -2 to the 10 minus 1, which is 6 times -2 to the 9th power, which is oops, I'm going to put parentheses around that -2. Oops, I did the wrong thing. 6 times parentheses -2 parentheses to the 9th power is -3072. Okay? So the 10th term, so instead of doing the 7th like they were asking, I'm changed it up and we're going to do the 10th term. Okay? All right, let's see. Let's go and look at number 19. It says the table to the left shows a car's value for 3 years after it's purchased. Write a rule to represent the depreciation. So just like in the table for the exponential functions, you look at the same thing. 8,000 divided by 10,000 is 0.80. Same thing if you do 6,400 divided by 8,000. Okay, so our ratio is, our common ratio is 0.80, and our first term is 10,000. Okay, now some of you may think, well, is this how much the car depreciated in 1 year? So that means the value when the car was purchased would be back here, right, at 0. So do we need to make that the first term? Well, in your formula, that n minus 1 is going to take care of that, because when we plug in for a term, it's going to back it up 1. So if I was to say year 1, it would back it up 1 and put to the, it would do 80% divided into the 10,000, okay? So that n minus 1 takes care of that question, okay? Because I know there's a few of you that I know would question and ask. All right, so our formula is going to be AN equals our first term, 10,000, times my ratio to n minus 1. All right, it says what will be the value of the car 10 years? So A10 equals 10,000 times 0.80 and 10 minus 1. So it's going to be to the 9th power, and you will get $1,342.18. Okay, so your car value in 10 years would be that. All right, so yeah, you can, this is the first term, so you don't have to go back like you do on the exponential tables. All right, we've got the independent practice to go with this. Remember, probably Thursday, we're going to have our unit test. Also, your notebooks need to be ready and turned in on Thursday as well. All right, have a good evening.